So let's start with the January 2023 exam of BT. In this they said find the currents I1 and I2 in the given network. So they didn't mention that it's a question of mesh analysis or nodal analysis. So that depends on you, but by whichever method you want to do, you can do it. Now according to you, tell me which would be more convenient to you. Like suppose in this I1 is there, so I'm marking over here I1. Okay, in this I2 is there, so I'm marking over here I2. Let us consider this one would be I3, this one would be I4, and this one would be I5. Okay, so now we'll have 5 mesh. For solving 5 mesh, we should have 5 different equation. Correct? Like if you'll have the current source, first make the equation from the current source. Okay, then after that second equation, after current source is completed, I3 and I4 wala, then second equation should be from the mesh. Okay, then after that mesh completed, then you have to take the super mesh. Okay, so now first equation is from the first current source, that I3 is equals to 25 ampere. Second equation from the second current source, that I4 minus I1 is equals to 20 ampere. Now after that we should move towards the mesh analysis, right? And tell me the equation of the mesh analysis. See, this is the equation of the super mesh. Minus 10 I1 minus 2 I4 minus I2 minus 4 I1 minus I3. This is the super mesh equation. Now can you make two equation from the mesh? This is one of the mesh and this is second mesh, right? So it would be minus I2 minus 10 I2 minus I5, then minus 2 into I2 minus I4 is equals to 0, and then we'll have the next equation, that is minus 20 minus 10 I5 minus I2 is equals to 0. Correct? So now we'll have the 5 equation. So basically 4 equation, so this one and this one and this one. We can solve it through calculator. Correct? Current source with the resistance is creating confusion only, and as you can see that both are connected in parallel also. Okay, so I'll suggest you, whenever the current source is connected in parallel with the resistance, then in that case it would be converted into the voltage source. Convert it always into the voltage source. Why? If you will convert the current source into the voltage source, then in that case your one mesh always reduces. Okay, so this is of 10 3, that would be 30 volt. So now this wire is eliminated and this point is connected like this. Now we'll have the simplified form of voltage. Let me mark the current direction I1, I2, I3. So apply KCL at node V1. It would be I1 plus I2 plus I3 is equals to 0. Correct? So I1 is moving from V1 to V2, V1 minus V2, and for the battery we have to take the second sign. Plus 40 divided by the resistance 6 ohm. I2 is moving from V2 to, this must be grounded, so V2 minus 0 divided by 2, and I3 must be moving from V1 to, we can convert this current source in parallel, right? We can convert this current source into the voltage source also. तो तुम्हारे लिए और आसान हो जाएगा. Otherwise you have to take the other node. एक और node लेनी पड़ेगी. ठीक है? तो convert करके would be easy, because after converting that would be reduced to a single mesh. So see how the diagram looks like. कुछ इस तरह का तुम्हारा डायग्राम हो जाएगा, राइट। दिस इज नोड V1, this is node V2 and this is node V3, correct. After this you can solve it easily. Now the next question, they ask you that determine the current across RL by using Thevenin theorem, right. So this one is RL. So first step, we have to remove RL. RL must be open circuit, right. You have to redraw the diagram every time. Now this is point A and this is point B, correct. Now you need to calculate VTH, that is equals to VAB. As I told you, just imagine that you are standing at A, you need to move towards B. So either you will move from the left hand side or you will move from the right hand side, right. So let's move it from the left hand side. So VAB would be equals to VAC plus VCD, okay. So it would be minus 10 I1 minus 50, then minus of. So now we'll have three equation, A to B, right. So this would be the value of VAB. Now to get the value of I1 and I2, we have to apply mesh analysis in both the mesh. First mesh equation is this one, another mesh equation is this one. After solving, we'll get the value of I1 and I2. We can substitute it over here, and then after substituting, we'll get the value of VAB, and that is equals to VTH, right. Now after that, what we need to do, we need to calculate RTH, and as you remember the steps, that for calculation of RTH, voltage source must be short circuit and current source must be open circuit, right. Now see, if we'll redraw the diagram looks like this. A is connected with C and D. So A is connected with C and D, and with C and D, अगर ये 10 ohm नहीं होता तो we can do it directly also, but C and D यहाँ पे 10 ohm is connected. So we can see simply that it will behave like a delta. Yes or no? And can we convert this delta into the star? Yes or no? If I'll redraw the diagram, then this 10 ohm as it is, 10 ohm as it is, right. Now I convert this delta into the star, right. So as you can see that this one and this one, they are in series, this one and this one, they are in series, right. And after that, they both are in parallel with series. Now what is the value of this delta? So as you know, 10 into 10 divided by 10 plus 10 plus 10. So it would be 100 by 30. 100 by 30 means 10 by 3. So with this is also 10 by 3, this is also 10 by 3, and this is also 10 by 3. Correct? So ये 10 by 3 as it is. ये 10 by 3 and 10 would be in series, right? 10 plus 10 by 3. Again नीचे से देखोगे तो 10 plus 10 by 3 is in series. तो अब ये दोनों किस में हो गए? पैरेलल में, and then we can solve it. तो वो किस में आ जाएगा? further series में. तो for this you have to use star and delta transformation. See at t equals to 0 minus 0 पे 1 पे कनेक्ट है, तो 0 माइनस पे कहाँ कनेक्ट होगा? 2 पे, right? Inductor will be replaced by a short circuit and resistor as it is, right? So that means there is no source over here, and no source means no current will flow, correct? If no current will flow, then in that case IL of 0 minus is equals to 0 only, correct? So IL of 0 minus is equals to 0. Now you have to draw the circuit at t equals to infinity. At t equals to 0, as according to the arrow is moved towards 1, right? So at t equals to 0, if switch is connected to position 1, then at t equals to infinity also switch should be connected to position 1 only, right? So resistor as it is, inductor will be replaced by a short circuit, resistor again as it is, and then we'll have the voltage source of 10 volt. Got it? This is 5 ohm and this is 2.5 ohm. So can we get the current over here? IL of infinity. IL of infinity is how much? V by R. V is 10 volt, resistance is 7.5. Can we get the current over here? Good. So now we need to calculate tau value. For calculation of tau, draw the circuit at t equals to 0. Tau formula is equals to L divided by R equivalent. L is how much? 10 millihenry means 10 into 10 raised to power minus 3. R equivalent we need to calculate it. R equivalent is equals to the RTH as we have done in the Thevenin. So for that, voltage source must be short circuit and inductor must be open circuit. So let's redraw the diagram. Voltage source short, inductor at t equals to 0, switch is connected to position 1, inductor must be open circuit, right? So we'll have only two resistance. Now as you can see, according to the RTH, like A and B, both are connected in series. So R equivalent is how much? 7.5 ohm. So that would be 10 into 10 raised to power minus 3 divided by 7.5. That is the value of tau. Now we need to calculate IL of t, and this is the formula. IL of 0 minus we already calculated, that is 0. IL of infinity we already got it, that is this value 10 into 10 raised to power minus 3 by 7.5. No, this is the tau, sorry. IL of infinity is this 10 by 7.5, right? So can we substitute it all the values? 10 by 7.5 plus 0 minus 10 by 7.5 e raised to power minus t by tau, right? Now see, read the question what they are asking. First they have asked the current. Now they are asked the current in the inductor when time they have provided at 2.5 millisecond. So we can put the value of time over here, that is 2.5 millisecond means 2.5 into 10 raised to power minus 3. Then after that we'll get the IL of t value. Okay.